Hi guys, we are going to talk about what atoms do when they combine. And then we're going to talk about different types of mixtures. So first, let's start off with the very basics. An element, we've already been talking about elements, but just to make sure we're on the same page, an element is made up of just one single type of atom with the same number of protons. Remember, the four most common atoms in your body are carbon, hydrogen, oxygen, and nitrogen. Those are the ones you learned about in biology. When you take atoms and put them together, and their atoms are sharing their electrons between them, then they form molecules. So in molecules, they specifically have to share their electrons. It can be made up of the same type of atom. So the oxygen that you breathe is O2. I picked some ones that you learned about in biology that are familiar to you. So again, O2 is one that you learned about in photosynthesis and respiration. Oxygen can be in the elemental form, although it's not very common to find it in the elemental form. It's not very stable. The oxygen you breathe in is two oxygen atoms coming together and sharing their electrons. Some other examples of molecules, most of the compounds that you learned about in biology are molecules. So C6H12O6, glucose, that's a molecule. All of these atoms are sharing their electrons. And carbon dioxide, what you breathe out and what plants take in for photosynthesis, that is also a molecule. The carbon and oxygen atoms are sharing their electrons to be stable. Compounds, a little bit different definition here. It's a substance made out of two or more different elements, and it doesn't matter whether they're sharing their electrons or transferring their electrons, as long as the atoms are together and there are two different elements. So like oxygen, the one we just did, O2, that's only one element, so that is not considered a compound. But glucose and carbon dioxide and water, which is also a molecule, those are all molecules and they're compounds because they're two or more elements combined. And then another one, table salt, NaCl, that is also a compound because it's two different elements, but technically it's not a molecule, and you wouldn't know this yet because we haven't talked about what sodium and chlorine do with their electrons, but they are not sharing them. They actually transfer their electrons. So technically it's not a molecule. Let's talk about mixtures. Mixtures are substances that contain two or more substances that aren't bonded together. So here, with these compounds and molecules, the elements are bonded together. The atoms are either sharing electrons and attached to each other, or they're transferring electrons, and they're attracted by a positive and negative attraction. Mixtures, though, you've got two substances or more. They're together in space, but they're not actually physically bonded to each other. There are two types of mixtures. There's a homogeneous or homogeneous, you could say it either way, mixture. It's a mixture where it's made up of multiple substances. They're in the same state of matter, and they're uniformly or evenly mixed. So you can't separate them. When you buy milk, you might see that it's homogenized milk. If you get like unpasteurized milk where it's not homogenized, then you'll see that the fat rises to the surface. That doesn't happen in homogenized milk. It's been mixed and pasteurized so that it stays mixed up. It doesn't separate out into two different layers. Tea is another example. 24 karat gold is an example. Syrup, Kool-Aid, lemonade is a homogeneous mixture. As long as it doesn't have pulp in it, it's a homogeneous mixture of the lemon juice and water. You can't separate them once you've mixed them together, and the mixture is the same at the top and the middle and the bottom, regardless of where you take a sample. It doesn't have to be a liquid. Well, I gave you an example, that's a solid here. It also doesn't have to be a liquid or a solid. It could be air. The air in this room is a homogeneous mixture of nitrogen and oxygen and carbon dioxide and some other gases. So it's the same. It should be the same at the top, the middle, and the bottom. You can also get a heterogeneous mixture. I should talk about what the prefixes mean. Homo means same. So homogeneous is the same throughout. Hetero means different. So this is a mixture that's different depending on where you take your sample. This is a picture of kefir, which is like a fermented milk. The longer you let kefir sit, the more homogeneous it becomes. So there's a bacteria and fungi in kefir that will change the milk sugar into different stuff. It'll break it down. So you can see this one looks pretty homogeneous. Same at the top, middle, and bottom. And then the longer you let it sit, the more it separates into the different layers. And this will happen with regular milk too. The fat will rise to the surface so that it's not the same throughout. If you get orange juice with a lot of pulp in it, that pulp as it sits will settle to the bottom. So then the bottom is different from the top. Same, you can think of other things too, like vegetable soup, right? You've got the broth and then you've got the chunks. And if you let it sit, the vegetables and other things in your soup will sink to the bottom and separate out. So mixtures, let's go back and talk about mixtures versus compounds. A mixture can retain the properties of the substances that are mixed together. So like in your vegetable soup, you have the broth with its properties. You have vegetables with their properties. The properties don't mix together, right? They still have the properties of the components that make it up. You can also change the proportions of the mixture. So you could add more vegetables in your soup, or you could drain off some of the broth if you have too much broth. Compounds have different properties, right? So it's not like water has properties of oxygen and hydrogen. It has brand new properties when those elements combine. And you also can't change the proportions. So water is always H2O. You can't add another oxygen, because once you add oxygen and you have H2O2, then you have hydrogen peroxide, which is a different compound. There are some ways you can separate a mixture. It depends on what kind of mixture you have. If you have a solid and a liquid mixed together, like our vegetable soup, then you could use a filter paper to separate it out. This is how you could separate your coffee, your water from your coffee grounds to make coffee. This only works if you have something that is big enough that the filter paper will catch it and not go straight through. So like this last one would not work with salt water because the salt is small enough that it would go through the filter paper. But with salt water, you could use heat to separate it. So they've got a mixture of water and salt here, and then they heat it up, and the water evaporates if you heat it long enough, and then you'll just end up with salt at the end. If you've got a mixture of something that's magnetic and something that's not magnetic, then you could use a magnet to separate it out. If you are mining and you're mining something and you've got lots of dirt in here that's not magnetic, and then you've got some iron ore in here, you could use a magnetic roller here to make the magnetic ore that you've collected go into a different container than the non-magnetic. Some of you in PLTW have used centrifuges. A centrifuge will spin a sample really, really fast around, and it'll separate it out by mass. So all the heavier stuff, you use this for blood a lot, like your heavier blood cells will go to the bottom of the centrifuge tube, and then the plasma, your liquid part of the blood that doesn't have as much mass, will sit on the top. You can decant to pour one phase away from the other. If you are cooking and you're making macaroni and you really don't want to get your colander dirty, You can pour off the water and try not to dump any of the macaroni in your sink. That's decanting. So you're pouring off the liquid and trying to keep all of the solid in your container, in your pot or your test tube. Chromatography is a way to separate. You could separate colors or pigments. This one's a pigment. You're separating out the plant pigments that plants use to do photosynthesis. They also have gas chromatography, which is used to separate gases. That one is used a lot in to make fragrances and in the food industry. It separates out by the size of the molecule and also the affinity, how attracted the molecule is to whatever you're running through your filter paper. Like with this one, this carotene here has a greater affinity for the liquid that's carrying the pigment up the filter paper. So it stays with the liquid as it rises up the filter paper. The chlorophyll B has greater affinity for the filter paper than it does for the substance taking it up the paper. So it stops first. And then distillation is another one. You can separate liquids by their boiling point. So you're heating up this liquid here, and the ones at the lowest boiling point will boil first, and then they'll go down the distillation tube and into the Erlenmeyer flask here at the end. So you can catch the first liquid with a boiling point, low boiling point, and then you can heat it up a little bit more. And then the next substance will start to evaporate and you can separate it out. So this is how they make concentrated alcohol. And they also make essential oils with this process too. All right, and that's the last one.